Hello guys, welcome to Ramta Solutions. Today we are going to look at how to determine the limiting reagent. So we are saying, of course, we are saying limiting reagents or limiting reactants. So we are saying when reactants are not fed in stoichiometric proportions, one of the reactants will be used up during the reaction and others will remain. Okay, so this, if you were a plant manager, would be a wasteful experience, right? You will be wasting material. So obviously, as scientists, engineers, and so on, you want to be using materials economically, right? You don't want to be wasteful. So now, what is happening now is this. With limiting reactants, if, for example, you are feeding substances, maybe dissolving aluminum into hydrochloric acid, you want to know the exact values that would allow you to not have a waste. Okay, to have a waste is, say, you want to dissolve your, let's say, your aluminum because you want to react aluminum with hydrochloric acid. That would be giving you aluminum trichloride, but you don't want to be having aluminum, right? You want to be using, or you want your aluminum to have dissolved altogether, all right? So, okay, let us not waste time. Let's get into what is happening with limiting reactants. So, what is happening with limiting reactants is, like I said, when your reactants are not fed in stoichiometric proportions, one of them will be used up while the others will remain. So, a reactant that is used up completely during a chemical reaction is the one we call a limiting reactant. Okay? It's the one we call a limiting reactant. And then the one that remains is called the excess, of course, excess. Okay? The one that remains is called the excess. Okay? So, now, let us now get into our calculations of how to, go about this. So, we will say for a balanced chemical reaction, let me go to the next page. I'm going to start writing for a balanced chemical reaction, okay? For a balanced chemical equation, rather. For a balanced chemical equation, let's say we have small letter A, capital letter A plus, small letter B, capital letter B, giving us small letter C, capital letter C, plus small letter D, capital letter D. So this is your balanced chemical equation, okay? So when you have a balanced chemical equation, you then are going to be given information that maybe you have a certain number of moles of substance A and a certain number of moles of substance B. What you need to know is, one, to find limiting reagent, okay? Find limiting reactant or reagent, it's okay. Do this. One, find a ratio of available substances, okay? Find a ratio of available substances. Two, find ratio or stoichiometric ratio. Find stoichiometric ratio. Okay, find stoichiometric ratio. This stoichiometric ratio, we will call it the required ratio. Okay, we will call it the required ratio. Okay, we will call it the required ratio. Now, number 2, if available, okay, if available is greater than required, I'm going to tell you this in bracket. Maybe let me just say, if available is greater than required, denominator, okay, substance you write in your denominator, denominator is limiting. Okay, now if available, remember, if the ratio of available substances is less than the ratio of the required substances, or according to stoichiometry, right? If the ratio of the required, if available is less than required, what this will mean numerator, right? It will mean numerator is limiting. Okay? It will mean numerator is limiting. So, you see, nobody has time to be cramming these things. So what we can do is, because we tend to use this a lot, I like using some mnemonic. Okay, I like using some mnemonic. So remember, a mnemonic is something that you use to remind yourself of things. So what I do normally, my mnemonic is like this. Check it out. It says, a green robe. I'm going to explain it to you. A green robe David loves. Okay? A green robe David loves. Now, I'm going to highlight some parts. A, G, R, D, and L. What does it mean? Check. How I like reminding myself of how to see which one is a limiting reactant. What I do is I say, remember, a green robe David loves. What does it mean? When available is greater than required, denominator limiting. Okay? So what do you do? A mnemonic, something that you'll always tell yourself even in the exam. A green robe David loves. Available, greater than, required, denominator is limiting. Okay? Denominator is limiting. All right. So this is a mnemonic that I like using. Okay? And you will see that in some topics, especially in physical sciences, there are some special mnemonics that I like using. A green robe David loves. I like this one. Available, greater than, required, denominator is limiting. So let's try examples. Now, examples. Let's start with, I'll take this one here. Let's say we have, let's say we have sulfuric acid, of course, in aqueous phase, plus ammonia in gas phase, giving us ammonium sulfate, in aqueous phase. What's happening? Okay, giving us ammonium sulfate in aqueous phase. Now further, they're saying to us the mass of sulfuric acid is 2,000 grams, and then the mass of ammonia is 1,000 grams. Then the question says, what is the maximum mass of ammonium sulfate? What is the maximum mass of ammonium sulfate? Right? So, before we proceed, I want you to see this. You have the quantities of both reactants. we are not sure if these quantities are in stoichiometric proportion, right? So let's see first and first if our reaction is balanced. Let's see. H2SO4, I see the SO4s are balanced. So maybe let me try to balance the nitrogens. When I try to balance the nitrogens, 2 nitrogen, 2 nitrogen, and let me see, we have 4 times 2 hydrogens, 2 times 3, 6 plus 2, it's 8. So maybe I should have used a different color. Let me balance it. Okay. So now it's balanced. Can you guys see that? It is balanced. Okay? It is balanced. So now what you also need to know now is this. We are given masses. We are not given number of moles, right? We are given masses. We are not given number of moles. So let's do this. Solution, I will say Mr. Oh boy. I will say Mr. H2SO4. What is it? It's 2 times 1 plus sulfur must be 32. Oxygen must be 16. All right, must be 16. So what do we have? Let's see. 34. We have 34 plus 4 times 16. This is 98 grams per mole. And then we have Mr. NH3. I believe nitrogen is 14. Hydrogen is 1. This is 17 grams per mole. Lastly, the question is looking for the mass of ammonium sulfate. So Mr. NH4 2SO4. What is it? It's 2 times 14 plus 8 times 1 plus 32 plus 4 times 16. Let's see. 28 plus 8 plus 32 plus 4 into 16. What is this? This is 132 grams per mole, right? So these are the molar masses of the 3 substances that we are looking for, right? So this question will be tricky for you because you are just given masses, you are not given number of moles. But because we have done mole mass ratios, we can do this easily. All right. Now let's find the number of moles of sulfuric acid. The number of moles of sulfuric acid will be the mass of sulfuric acid over Mr. sulfuric acid. Right? What is it? It is 2000 grams over 98. I'm going to write it to correct to 2 decimal places. 2000 divided by 98. So this is 20.41. Then I'm taking number of moles of ammonia. Number of moles of ammonia is equal to the mass of ammonia over Mr. ammonia and NH3, sorry. So what is it? I think it was 1,000. And yeah, it was 1,000 over 132. Is that so? Yes, it was 1,000 over 132. Okay. Yes, it is. So, yes, it is. So, 1,000 divided by 132, correct to 2 decimal places, it will be 7.58 mole. All right. it is 7.58 mole. Oh no, sorry. Oh boy. No. For ammonia, it's not that. It's 17. Oh boy. It's 17. Cannot be that. It's 17. It's 17. Oh boy. Wow. It's 17. So it's 1000 divided by 17. So this is 58.82 moles. Correct? Now, I do not need to look at the number of moles of, what is this? In fact, I cannot as yet find the number of moles of ammonium sulfate. So as you can see, we are given two substances and their masses. So we need to know how they are fed into the system. So let's look at the available ratio. So available ratio is equal to number of moles of, let's say, sulfuric acid. I'm going to take sulfuric acid over number of moles of ammonia. What is this? This is 20.41 over 58.82. What is this? Let's see. 20.41 over 58.82. What is this? This is 0.35. Okay, this is 0.35. Now, let's look at the required ratio. The required ratio is, let's look at it. 1 mole, as you can see, 1 mole sulfuric acid. It's 1 mole sulfuric acid over 2 moles ammonia. What is this? This is half, which is equal to 0.5. Now check this out. Remember a green robe that David loves, right? So what you are seeing here, you're seeing that available is less than required. Now, if you recall, remember a green robe that David loves, right? Let me write this in a different color. A green robe that David loves, right? So a green robe that David loves, if available is greater than required, denominator will be limiting. But this time, available is not greater than required, but rather available is less than required. Therefore, if available is less than required, it means numerator will be limiting, right? Numerator will be limiting. So note that available is less than required. Therefore, H2, back to, right? H2, or maybe I should say this. Yes, available is less than required, right? Available is less than required. Therefore, H2SO4 is a limiting reactant, right? Is a limiting reactant. Okay? Remember, when available is greater than required, denominator will be limiting, but now available is not greater, it's less than. So this means numerator will be the limiting reagent. Now that we found the limiting reagent, the maximum amount of mass that you can produce is subject or is related to the amount of substance of the limiting reactant. Okay, so let's do this. So when you look at it, the number of moles of sulfuric acid, or maybe let me not take sulfuric, let me start with this guy here. The number of moles of ammonium sulfate over what is its coefficient? It's 1 is equal to the number of moles of sulfuric acid. What is its coefficient? It's 1. What does it mean? It means the number of moles of ammonium sulfate is equal to the number of moles of sulfuric acid, which is equal to, let's go, the number of moles of sulfuric acid was 20.41. Okay, so this is 20.41 moles. As you can see, this means the number of moles of sulfuric ammonium sulfate is equal to 20.41 moles. Now, let's find the maximum mass, or the mass of ammonium sulfate. What is it? We said, to find the mass, we know that N equals M over mass. So this is NH4 2 SO4 equals mass of NH4 close sub 2 SO4 all over mass NH4 2 sub 4. Alright, now let's substitute. We said the number of moles of ammonium sulfate is 20.41. So we have 20.41 equals the mass. What is the molar mass? I think it was 132. Yeah, 132 over 132. Therefore, the mass of this guy is equal to 20.41 multiplied by 132. What is it? It is equal to, let's see, 20.41 multiplied by 132. What is this? This is 2,694.12 grams. Right? So this is the maximum amount of ammonium sulfate that you can produce. Okay? This is the maximum amount of ammonium sulfate that you can produce when you feed these substances into your reactor. Remember, guys, when you are giving 2 substances or whatever number of substances, let's say 2, the products that you are getting will always be with respect to the amount of the limiting reactant. Okay? It will always be with respect to the amount of the limiting reactant. Okay? So with that being said, it's a wrap, and see you next time. Bye bye.